First of all, I would like to welcome everyone for participating in our AMC8 Plus summer practice program. In this video, we'll go over problems in the first assignment. Let's look at question number 1. The problem says a box contains 4 different balls. Let's say 1, 2, 3, 4. Students in Mr. Lee's class take a turn to take 2 balls and then put them back. What is the minimum number of students to ensure that there are at least 5 students who get the same 2 balls? First of all, if we want to choose 2 balls out of 4 balls, the number of different combinations, okay, so we get the number of combinations equals from 4 choose 2, right, by these combination formulas, 4 times 3, 2 times 1, which equals 6. So this is the total number of different combinations we have. Right, so the question is, we want to guarantee there are at least 5 students who get the same combination. Let's think of the opposite scenario. Like, what is the largest number of students to avoid, right? So that we can avoid to have 5 students who have the same number of, who have the same 2 balls or the same combination. Okay, so then let's think of the worst. We think of the worst scenario, well, of the opposite. And what we can do is, of course, for each one, we choose 4, right? So that's the best we can do. And this we choose 4, and each one we choose 4, right? Okay, so this is also choose 4. So this is the best we can do to avoid, right? So to avoid 5 students who have the same number of, who have the same combination, right? So that's 4 times 6, which is 24. Therefore, if we just add 1 more, right? So if we add 1 more, then it becomes inevitably we'll get at least 5 students who have the same combination. So the answer is 25. Question number 2. Here we have a 3-dimensional figure that consists of cubes of side lengths. This is 5. Here we have, this is 2, and this is 1. Now, what we want to find out is the surface area of the 3-dimensional figure. Okay, so first of all, let's see. If we look at those horizontal parts, right, those flat horizontal parts, and we can just compress, right? So if I project to the top of this big square, the big cube, we see it just gives us the top surface of this bigger cube. Okay, and therefore what we get is this, right? So okay, so we just get, first part is just all the surfaces of this bigger cube. That's what we have. All right, so each one is 25. Okay, I put this in the part 1, right? So it's 25 times 6, that's 150. And the second part we look at is, here we have the second layer. So this is 4, right? So those vertical parts. All right, so in total, we have those 4. This is 4. Well, how many we have? We have 4 times 16, right? So because each one has 4. If we look at the vertical part, each one has 4 faces, 4, so 16. And this is 64, right? So this we call like part 2. And then we part 3. Part 3 is the vertical part of this small one, right? Again, we have 1, right? Each one is 1, but how many squares do we have? We have 16, right? So then we get is 16, right? So this we call part 3. Now we just add them together, right? We have 150, we have 64, and then we have 16, right? So then we get a total, right? So I get a total, I just add them together. We get is 100, we say, okay, I get 150 and plus 64 and plus 16. So we get is 150 plus this one is 80. So that's 230. Question number 3. 5 people are sitting around a circle, and some always tell the truth while the others always lie. Each person claims to be sitting between 2 liars. How many of them are telling the truth? Well, it's easy to see that at least one of them is telling the truth. Why? Because all of these 5 people are liars. Then you think of one liar, that he's sitting between 2 liars. Then he said, okay, I'm sitting between 2 liars, which is the truth, not a lie. Okay, so it's clear. At least one of them is telling the truth. Let's say this one is telling the truth, so it's either true. But because he can choose, everyone said that he's sitting between two liars. That is okay. So we get this one is a liar, and this one is also a liar. Now the question is, how about the other two? Is it possible that both of them are liar? Well, it's not possible, because let's say if this is liar, then this one actually tend to choose, because he said both of his neighbors are liars, so which is impossible. Okay, so we know this is just impossible. So okay, we can remove this situation. It's impossible. Now, is it possible that both of them are telling the truth? Well, that's impossible, because if this one's telling the truth, then he says both of them are liars, right? But this guy is telling the truth, so this is impossible. All right, and this tells us the only valid scenario is this one is telling the truth, and this one is a liar, or the other way around, or this one is a liar and the other guy is telling the truth. And that is the only valid arrangement. Okay, so if we look at the number of people who are telling the truth, is 1, 2, and the other way is also 1 and 2. So the answer is 2. Question number 4. The problem says here we have a triangle ABC. It is an isosceles right triangle. Triangle ABD and triangle ACE, they are both equilateral triangle. And the question is, based on those assumptions, what is the angle ADE? There are different ways to solve this problem. What I will do is, you see, because all those sides are the same, since it's isosceles right triangle, and then we do equilateral triangles. Okay, so then I get this one is 60 degree because it's equilateral triangle, 60 degree, right? This one is 90 degree. It's a right triangle. Okay, this quickly tells us the angle of ADAE, right? The total is 360. So we just subtract those numbers. So this is 360 minus 90 minus 60 minus 60. And this, what we get is 360 minus 220. So that's 150. Okay, so 150 is the angle of DAE. Let's put 150. Now we have isosceles, right? So this is isosceles triangle because all those sides are the same. And given a triangle, let's recall, right? Given a triangle, regardless what it is, if I add all the three angles together, so angle 1 plus angles 2 plus angle 3 is always 180. And if I have isosceles triangle, right? So if the two sides are the same, then the corresponding angles, they're also the same. Right? So from here we get, okay, so this angle will just twice of this angle equals 180 minus 150, which is 30. And this immediately tells us this angle, which we're looking for, is 30 divided by 2, which is 15 degree. Question number 5. If fractions are arranged according to the following pattern, at which position does the number 7/11 appear? First of all, let's identify the pattern of the sequence. The first one is just 1/1, right, which have 1 here. The second section is from 1 to 2, right? Numerators from 1 goes up to 2, and denominators goes down from 2 to 1, right? So it's 1 to 2. So we have one number here, we have two number here, and then we have 1, 2, 3, right? So this is just 1, 2, 3. You have 3 numbers here, and here have 1, 2, 3, 4, right? 1, 2, 3, 4. We have 4 numbers here, and then we have 5 numbers here, right? 1, 2, 5. Okay, we have 5 numbers here. Right? So we can divide the sequence into those portions 1, 2, 3, 4, 5, and 6, and such and such. Let's see at which section 7/11 is in. Clearly, we have 7/11. Now we start from 1 over something, right? Okay, so 1 go to 7, we plus 6, and because the numerators are going down accordingly, so from here we should just minus 6. Well, in other way, we just have if the sum of the numerator and denominator, if we add them together, it's the same. All right. Okay, anyway, so here we just get this one shall be 17, and it tells us it is in the portion is 1, 2, 3, and all the way to 17. The last guy is just 17/1. Now before it, of course, is the 16 section, and this is 15 section, and all the way to the 4th section. Now then the total number, we get the total number of fractions right, up to here, right? So this is the one we're looking for, is 1 plus 2 plus 3 and all the way plus 16, and then plus from here to 7, so it's which is plus 7, right? So that's the last one. We have 7 here. Okay, so let's calculate this. The way we calculate 1 plus 3 plus 16, we just apply Gauss formula. It's 1 plus 16, the last one, multiplied by 16 divided by 2 and plus 7, and which is 17 times 8 and plus 7, and this one is 136 and plus 7, and that's 143. Right? Okay, so 7 over 11 is on the position 142nd, third, right? 143rd. That's the position of this number, 7 over 11. Question number 6. The distance between location A and location B is 1,000 meters. Both Abel and Ben start from location A. Abel, so here we have Abel runs toward B with a speed of 160 meters per minute. After Abel arrives at B, he first around to B, and then immediately returns. Okay. For Ben walks toward B with a speed of 40 meters per minute, and then they will meet at some place. The question is, how far is Ben away from location, which means what is the distance of this when they meet at some point between A and B? Well, because we know Ben's speed is 40 meters per minute, well, in order to find the distance, we just need to know the time. Okay, well, let's use a little algebra. Okay, so I let the x be the number of minutes that Ben walks, well, which is the same as the number of minutes that, which is the same as the number of minutes that Abel runs, right? Because they start at the same time. And then we know, okay, distance equals time multiplied by speed. And then we have this one, this part will just be, it's 40 times x. And the part of this part, the red part, right? So from the travel distance of Abel, if we add together, this will be just 160 times x. Right? So that's the travel time of Abel. Now, if we add this together, you see, if we add these two things together, so part of Abel, that's Abel runs and put the Ben works total is exactly twice of the distance, right? So the point is Abel plus Ben equals twice of the total distance, 2 times 1,000. So that's 2,000. And this is 40x, and this is 160x. So both are speed multiplied by time. So add together. Okay, so from here, we quickly get 200x equals 2,000. So we get x equals 10. So 10 minutes. So that's the number of minutes. That's the number of minutes that that Abel worked, right? Abel worked. Okay. Now we have, so from here, then we get the distance equals time times speed. So 10 times 40. So that's 400 meters. Question number 7. Fx is a function defined on positive integers, satisfying for every 2 positive integers m and n. We have the f evaluated on the multiplication equals the multiplication of corresponding values. Now, if we know the value of f at 2 is 1 and the value at 3 is 2, the question is, what is f72? Now, clearly, because we can decompose the value of f in terms of the product of inputs. So what we should do is write 72 as the product of given numbers 2 and 3, because we know the value of f at 2 and 3, and then we should write 72 as the multiplication of 2 and 3. Okay. We know 72, which is 9 times 8, that is 3 squared. 3 squared times 2 to the 3, right? 2 to 3. So that's how we write it out. Okay. All right. So then I have f 72, which is just F9 times 8. It's okay. So this is just F9 times F8. F9 times F8. So that's because just how we define it, right? So that's just how we define it. Okay, so this is the multiplication. All right, now F9, 9 is equals, this 9 is 3 times 3, right? So this we go, okay, we can just do one more step, 2 times 4, right? So this one is just F3 times F3. So this one, and this one, okay, is F2 times F4. Well, but F4, we know that 4 is 2 times 2, so we can further write this as F2 times F2. Accordingly, if we collect all those together, we just get F72 is equals, sorry, 72 is 73 squared times to the cube. All right, so we just F3 times F3 and times, here is F2 times F2 times F2, right? We can just write as F3 squared. So it's the CC, it's the same powers, 2 squared, and then times F2 cube, right? So you see this is a cube, this cube. It's the same because it's exactly follow the multiplication. Now F3 we know this is 2 to the square because this guy is 2, and F2 is 1, so it's 1 to the cube. Now if you combine those things together, we just get the answer is to the square, that is 4. Question number 8. The problem says cylindrical glass of diameter 6 centimeter and height 11 centimeter is filled and then tilt to 45 degree. Okay, so let's say this is the ground and tilt to 45 degree and some water overflow. So how much water is left in it in terms of cubic centimeters? All right, let's first mark all the numbers given in the problem. Okay, so the height is 11, and then this is the diameter. If we connect the diameter of the base, right, so this one is 6. Okay, now the angle is 45. Then this one, of course, if I connect this, right, so this is also 6. I connect this point to that. Okay, now this one is 45. The water level has to be parallel to the ground. That's because of gravity. All right, so then we have this is 45. This is 90, and this is 45. Okay, this is 6. Now we need to, this is 6. All right, here, this part is 6. Now we want to calculate the volume of the water. We can separate into 2 parts. So this is, say, it's part 2, and this is part 1. All right, here we have 6. And for part 2, the height then will be 11 minus 6, that is 5. Let's recall how we calculate the volume of a cylinder. Say if I have a cylinder, cylinder is determined by 2 parameters. One is the radius, that's R, and the other one is the height h. And then we know the volume is given by pi times R squared times h. And for this one, for the R, for the part 1 R, so for the part 1, we know, okay, so the radius is equal to 3, right? So the radius is 3. So that's pi times 9 times, which is 3 squared, and times 6, that's the height. So which is 54 pi. Okay, 50 pi, that's for the part 1. But if we calculate the water is half of it, right? So this is half of it. So it's 1/2 times 54 pi is 27 pi. Now we want to calculate the second part, part 2. Part 2 is just pi times, again, the radius is 3 squared and the height is 5. Okay, so it's 45 pi. Now we just add them together. So 27 pi, 45 pi, we add them together, 27 pi plus 45 pi, and this will give us a 72 pi. So 72 pi is the volume of the remaining water. Question 9. 3 groups have the same number of kids. Group 1, group 2, and group 3. The ratio of boys to girls, in the first group is 1 to 2. The second group is 1 to 3. And the third group is 2 to 5. The question is, if we combine all 3 groups together, what is the ratio of boy to girls? All right. Now for this problem, what we can do is, let's just do a little algebra. If I let x is the number of kids in each group. Because they have the same number of kids, so this is x, and this is x. All right, so therefore, if I combine them together, the number of boys in total equals, the first one is just 1/3 of x. The second one is 1/4 of x. The third one is 2/7 of x. And then we look at the number of girls, right? We look at the number of girls by the given, again, by the given ratio. We have 2/3x and plus 3/4x and plus 5/7 and x. Now I introduced this x, but it's not really used because we can just cancel, we can pull out the x and cancel from the numerator and denominator. What we left is just the ratio of two sums of fractions, 2/7, and there's 2/3 plus 3/4 and plus 5/7. Now what we want to do, of course, we want to transform the numerator and denominator to whole numbers, and then we use a common multiple. If I do 2, 4, 3, right? If I look at what is the LCN of 3, 4, and 7, which is 84, right? Because they are mutually relative prime. What I do is I just multiply 84 on the numerator and denominator, and this will give me the first one. After some calculation usage is 73, and the numerator will be 179. And the two guys, they are relative prime, so we don't need to do any further reduction. Question number 10. The three-part integers a, b, c form arithmetic sequence, while the integers b, c, d form a geometric sequence. Now, if we know that b, c over b equals 5/3, what is the smallest possible value of a plus b plus c plus d? Okay, now, because we know that a b, c, d is a geometric sequence. Geometric sequence means the ratio is the same. From the next one to the previous one, the ratio is the same. If we let, for convenience, let's say I denote b as the value. Okay, so this is b, capital B, and then the c will be 3, 5 times b. So here we have the common ratio is 5/3. And then if we move to the d, we also multiply by 5/3. So that's 25/9 times b, which is d. Okay, now let's look at arithmetic sequence. Arithmetic ABC is an arithmetic sequence. That means it has a common difference when you move from the previous one to the next one, right? So B is B, and C we already know is 5/3B. Okay, so here we know the common difference is we add 2/3B, and this is also from A to B is also added 2/3B. So therefore, we get A is just B/3. Okay, all right. So from here we deduce A plus B plus C plus D. We can express this in terms of B, and this is B/3 plus B and plus C. C is 5/3B and plus D. D is 25/9 and B. Okay, now what we want is we know that A, B, C, D, A, B, C, they are all integers, and B, C, D, they are also integers. So all A, B, C, D are integers. Now, in order to be integer, okay, so we need all those four, they are integers. Now, in order to be integer, the B, well, we have to be divisible by 9, right? So we get least B equals 9, right? It's equal 9 to be divisible by 9. Okay, so if we let it B equals 9, here we get is 3 plus 9 plus 15 and plus 25, and we add together, we get is 52. Okay, it is 52. So 52 is the least possible value of A plus B plus C plus D, given all those assumptions. Question number 11. What is the area of the smallest circle that can completely cover the following polygon? Here, all angles at corners are assumed to be 90 degrees. Well, intuitively, it is clear. If we want to find a circle that contains this polygon, the radius of the circle shall be the longest distance between 2 points on the polygon. So here what we have, the longest distance is the distance between 2 corners, right? This can also be seen if we complete the polygon into a rectangle, which is actually a square, because if we look at this side is 6 plus 2, which is 8, And this side is 2 plus 2 plus 4 is also 8, right? So equivalent. So the point is to find a circle that contains this polygon is equivalent to find a circle that contains this square 8 times 8. Okay, and from here we get by Pythagorean theorem, let's say the D is the diameter. So D is diameter of the circle. We get D squared equals 8 squared plus 8 squared, which is 128. And then the area of the circle, right, which is pi times r squared. R is the radius, so radius d over 2, and that is just pi times d squared and over 4, right? So we get as pi times 128 over 4, and this gives us is 32 times pi. And this is the area of the circle, the smallest circle that contains this polygon. Question number 12. Let n be the largest number that is no greater than 2021 and has remainders 2, 3, 4 when divided by 3, 4, 5 respectively. What is the sum of digits of n? Okay, so here we know that n, when divided by 3, the remainder is 2, right? This is the notation to denote that. Divided by 3, the remainder is 2. And when divided by 4, divided by 3, the remainder is, when divided by 4, the remainder is 3. And when divided by 5, the remainder is 4. Divided by 5, the remainder is 4. Now here, when you first look at this, you see all those remainders are different, which is kind of hard. But nevertheless, the key is to realize we can change the 2 to be -1. So if we use negative remainders, so this is also when if divided by 4 through 3, which you can say in the remainder is -1, and 5, this is also -1. The point is by using negative numbers, we can convert different remainders to the same remainder, -1. And this is equivalent to saying that n minus -1, which is just n plus 1, this one is divisible by 3, 4, and 5, and which is equivalent to saying that it's divisible by the LCM, that is 60. Right? So n plus 1 is divisible by 60. So n, when divided by 60, the remainder is -1. From here, we say, okay, that means the n can be written as 60 times some integer k and -1, right? And we want this one to be, okay, so here the requirement is no greater than 2021. Okay, when this is less than 2021, and we find the largest k to make this work. We find the k, the largest k work is k equals 33. And if we plug k equals 33 to here, we will just get n is 1979. And then if you add all the digits together, the sum equals 26. Question number 13. How many positive integers are factors of 8 factorial, but not factors of 7 factorial? First, what do? We do factorization. Prime factorization of both 8 factorial and 7 factorial. And then we identify those factors, which those numbers that are factors for 8 factorial, but not 7 factorial. Okay, when we do 8 factorial, it obviously 2 is a prime factor of 8. If you look at this multiplication, we know, right, 8 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 and times 8. Now 2 appears in 2, 4, 6, and 8. If we collect all those factors together, this will be to the power 7. And then we have 3 to the square, because 3 only appears in 3 and 8. And then we have, it's 5 and the 7. Similarly, 7 factorial, well, it will be 2 to the 4 and 3 squared times 5 times 7. Now, if we compare the two, we say, okay, if say n is a factor of 8 factorial, but not 7 factorial, but not factor of 7 factorial means it's going to say that n can be written as 2 to some power. So the power could be, it has to be greater than 4 because we don't want to be a factor of 7. So it's either 5, 6, or 7. And 3, it has to be factor of 7. So it's be either 0, 1, or 2. 5 will be either 0, 1, and 7 also 0, 1. Okay, so then by multiplication principle, right, we apply the multiplication principle. The total number of combinations, here we have 3. So this one have 3, and this also have 3. This have 2, and this have 2. So that's we multiply together, we get is 36. So in total, there are 36 numbers that are factors of 8 factorial, but not 7 factorial. Question number 14. Two people, A and B, take a turn to flip coins. The game ends whenever one of them gets 2 heads. A flips first. What is the probability that A flips no more than 3 times before the game ends? Here, we'll consider the opposite case first, which means what is the probability that A needs to flip more than 3 times in order for the game to end. And then if we figure out that probability, we just use 1 to minus that, right? Okay, so we'll look at the probability that A needs to flip more than, we say, let's say at least, well, which is couldn't say at least 4 times. Now, that event is equivalent to the following. Say A go first, and then B, and then A, and then B, and then A. Now, if A needs to flip at least 4 times, means if I look at the first 6, right? First 6, right? 3A, 3B, none of them, A or B, get 2 heads, right? And then if that's the case, so this is equivalent, right? So this one just equivalent. In the first 6 times, neither A nor B get 2 heads, right? And then if that's the case, then the game has to continue, well, it has to continue and move to A and blah, blah. That means it has to flip at least 4 times. Okay, well, then this just means it has two things happen simultaneously. A, so if A flip 3 times, and then B, and then B flip 3 times, right? Okay, no 2 heads. Right? Okay, now for this one, it's easy to calculate because the total number of scenario is 8, right? It's 2 times 2 times 2. And then 8, we have to minus the case that it has 2 heads. If exactly 3 heads, 2 heads, so this minus 3 and minus 1, right? So this one means exactly 2 heads. And this one means 3 heads, right? So the point is, if it had 2 heads, it has 2 cases. Case 1, exactly 2 heads, right? Head, tail, head, right? Exactly 2 heads. Or it could happen is all are heads. But for both cases, we get at least 2 heads, right? Okay, all right. So then if we get that, we just get this equals to 4/8, which is 1/2. And similarly, this one is also 1/2, right? Okay, so no, so for both, we are calculating no 2 heads scenario. And then because they have to happen simultaneously, we get is 2 times 2, right? If neither A nor B get 2 heads, this will be 1/2 times 1/2 because it's independent, so happen simultaneously, so it's 1/4. Okay, so the probability needs to flip at least 4 times is 1/4, and then the probability, what we are looking for. So from here, we just deduce, right? From here, deduce the probability that A flips no more than 3 times will just be 1 minus 1/4, which is 3/4. Okay, so for this problem, the key is to look at the opposite. What's the probability that A needs to flip at least 4 times? And then to realize that's just equivalent to saying, if I look at the first 6 times, right? A 3 times, B 3 times, then neither A or B nor B get 2 heads, right? Either it's exact 2 heads or 3 heads, right? Okay. Question number 15. Here we have 15 numbers, 1, 2, 3, 4, all the way to 15. And we divide these 15 numbers into 2 groups, group 1 and group 2. Group 1 and group 2. So that the sum of numbers in group 1 equals the average of numbers in group 2. Now we also assume that both groups have at least 2 numbers. The question is how many numbers are in group 2? Okay, let's do some algebra. If I let X is the sum of numbers in group 1. Okay, so that's X, and N is number. Okay, so that's what we are looking for. So how many numbers? N. So N is the numbers of numbers in group 2. And because X, we know that X is the average, right? So this is the sum. And this sum will just be N times X, because X is the average of the numbers in group 2. So N times X will be sum of numbers in group 2. Okay, now because group 1 and group 2, if we combine them together, it's just this total of 15 numbers. From here, we deduce the X plus mx is 1 plus 2 plus 3 and all the way to 15. And we apply the Gauss formula. This is 1 plus 15 times 15 divided by 2, and this is 120. And both, of course, both X and N, and those are their integers. And we do a simple factorization. So this is, we can pull X to the front. So X times N plus 1 equals 120. Now, this tells us X and N plus 1, they are both factors of 120, but not every factor is eligible. Seems you see, because X is average, right? It's average of numbers in group 2 is average. Well, average cannot go beyond the 15. So we have X has to be less than 15. And number 2, N is how many numbers in group 2, and N, and also has to be less than 13. Well, it has to be less than 13 because no greater than 13, because we assume that in each group has at least 2 numbers. So it's between 2 and 13, right? Between 2 and 13. Now, if we combine these 2 pieces of information together, it's not hard to derive. There's only one valid value for X, which is X has to be 10, right? If X to be 10, we just get N equals 11, right? So that means this one has 11 number and group 1 has 4 number. The sum is 10. Okay, and then it's easier to, well, we already get the answer, but we can verify the answer by finding those numbers. So from here, we actually can derive the numbers here is 1, 2, 3, 4. You see, if you add them together, you get exact 10. And for the remaining is 5, 6, and all the way to 15. So this is exactly how we split these 15 numbers. Okay. Question number 16. Here we have quadrilateral ABCD, which is trapezoid. AB is parallel to CD, and we know AB is 25, and CD is 37. Okay, BD is a diagonal, and AC is another diagonal. Now we choose their middle point F and G. The question is, what is the length of F and G? Okay, so there are different ways to do this problem. For me, I think the most convenient way is we extend F and G to this point. Let's say it's H. Now, here the key is I claim this H is the middle point of B and C. Now, why is that? Okay, so this is a claim. I claim the middle point. Now, why is the middle point? Okay, so what we can do is if I choose, let's say F, I choose this is middle point, and then I choose the H to be middle point of BC. All right, now I connect F and H. Okay, I connect F and H. The point is, let's recall some basic facts. Say if I have a triangle, and this is middle point, this is middle point. So let's say this is middle point, and this is also middle point. Say this is N and N, right? 2 middle point. Okay, and then this N we have this is the same as this is the same as that. Then we have N and N. Let's say this will be just D, and the N and N will just be D over 2, because we have this similar triangle, and they are this one and this one, they are just parallel with each other, right? So this is basic fact from similar triangle. We have the ratio 1 to 2. Okay, so now if this is the middle point, this is the middle point, and then we know the FH will be parallel to CD, right? But also CD is parallel to AB, so we have FH is parallel to AB. Now, if FH is parallel to AB, we just use this similar triangle. This is 1 to 1, and therefore this is also 1 to 1, right? So here we have, let's recall, for a similar triangle, we have basic scenario is this. If I have this 1 to 2, they are parallel, then we have this triangle is similar to the bigger one, right? These two things are similar, and they have the same ratio, right? So they are similar, have the same. Similar means two triangles, they have different size, but with the same shape, or with the same side ratio. Side ratios. Okay, so then there's this point, it has to be the middle point of AC, right? So this tells us why, if I extend it, the edge has a middle point of BC. But after that, and combined with what we have here, I have what is the F edge. I get the F edge. This one will just be 37 divided by 2. And then we have what is the G edge. G edge will just be half of the AB, right? So this will be just 25 divided by 2. And then the FG. FG is difference of this F edge minus this G edge. So this is 37 over 2 minus 25 over 2, which equals 22 over 2. That is 6. Right. So for this problem, the key is we utilize this fact, right? This simple fact. For a triangle, if I choose middle point of two sides, and this side is parallel to this side, and the ratio is 1 to 2, because here is 1 to 2. Okay, and this is a typical scenario of symmetry triangle. If I know this is one and this one, they're parallel, then this triangle is similar to this bigger one, and therefore all the ratios are the same. Question number 17. Let n be the number of 4-digit numbers whose all digits are positive and add up to 13. What is the remainder when n is divided by 7? Okay, what we are looking for is 4-digit numbers A, B, C, D. It satisfies all the digits A plus C plus D, they add together equals 13. And also we need them to be positive integers. So A, B, C, which means none of them is 0, it's no less than 1. All right, and we will find how many this kind of 4-digit numbers do we have. First, let's recall how we find the number of solutions of this Diophantine equation, A plus C plus D equals 13. What we use is the insertion technique. Sometimes it's also called a bar and ball technique. Well, it goes like this. Well, you want to find a 13, right? So, okay, I just write 13, 1, so what, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So that's what we have. Now, in order to find the ABCD, this is ordered ABCD, all you need to do is you just need to put 3 bars. Let's say, okay, so here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 positions. Right? You just choose 3 positions to put 3 bars. Well, like if I can divide these 11 ones into things like this, you basically get a solution is 3 plus this is 4 and plus 2 and plus this is 4. Now the point is by choosing different positions for these 3 bars, we just get a solution of A, B, C, D. Now clearly, so the number of ways, so the number of solutions equals, it's from 12 position, 12 spots, we choose 3 out, right? So this is 12 times 11 times 10, 1 times 2 times 3. Okay, so we get this is 2. Okay, so that's 220. So this is the number of solutions to A plus B plus C, right? So this is number of solutions, positive solutions to A plus B plus C plus D equals 13. However, here we require, because we are not just solutions, we also need them to form a 4-digit numbers. That means we need to A, B, C, D. They have to be less or equal to 9. Okay. So we need to exclude those invalid ones. What are those invalid ones? Well, that means one of them is bigger than 9, right? And that what we have is 10 plus 1 plus 1 plus 1 equals 13. And of course, we can also do like this, right? We can plot 10 plus 1 plus 10 plus 1 and 1 plus 1 plus 1 plus 10. All right, so we have 4 invalid ones. We have to exclude them. And then we get the number the number, the final number equals 220 and minus subtract these 4 invalid ones, we get this 120, 116. This problem asking for what is the remainder when this one divided by 7. So it's 3, 21, and 6, 0. So we get the remainder is 6. Question number 18. In the following triangle ABC, EF are points on AB and AC respectively. The areas of quadrilateral AFPE, triangle BPE, and the triangle CPF, they all equal to 4. The question is, what is the area of BPC? All right. Okay, so what we'll do is let's connect the A and the P. I denote this is the area of PF A is X, then this one will just be 4 minus X, and let Y to be the area of, or Y to be the area of BPC. Okay, so X is area of triangle PFA, and then Y is the area of triangle BPC. That is what we are looking for. All right, to solve this problem, a basic but important factor we use is the following. That's what we call this basic effect. If I have 2 triangles, they share the same height. Let's say this is triangle 1, this is triangle 2. They share the same height, which is h. Okay, and then we know the area of triangle 1 over the area of triangle 2 will just be the ratio between corresponding base. Okay, let's say this is A and this is B, then it will just be A over B. All right, we're just going. This is the fact we're going to use to solve this problem. All right, and then by this we know if I look at the 2 triangles 4 and 4 minus x, I'll get a 4 over 4 minus x. That's the area of these 2 is the ratio between BE and EA, right? So we say, okay, so this is BE over EA. But meanwhile, BE over EA, if I look at these 2 triangles, the BEC and this is CAE, okay, so this is also equals to Y plus 4 over, and the other one is 8 because it's, this is just 4 plus 4, right? Okay, similarly, if I look at these 2 triangles, 4 and x, so I have 4 over x. This is the ratio of CF to FA, right? So, okay, so it's the same as CF to FA. It's just the corresponding base, right? But if I look at CF to FA, I can also, it just be the triangle of these 2, right? So if I look at the triangle of these 2, okay, so this will be as this Y plus 4, and again it's 4 plus 4, which is 8. Now, what we observe, you say, okay, wow, these 2 things, they are exactly the same. Both are Y plus 4 over 8. Okay, from here, we deduce these 2 things are the same. Okay? And this tells us is 4 minus x equals x, so that means x equals 2, right? If x equals 2, and then we'll just get from here, we say, okay, so then I'll just derive 4 over 2 equals Y plus 4 over 8. And then this tells us Y will be equals 12. Now, here, of course, some of you might think, well, if I assume at the beginning the triangle is symmetric, let's say it's isosceles, AC equals AB, and then if I connect AP, then then it's obvious it's split into 2 even parts, 2 and 2. But here, what I want to emphasize is, regardless in which situation, right, you don't have to assume the triangle is isosceles. But as long as we have this arrangement of areas 4, 4, 4, then by this argument, we will get if if you connect AP, then it will split the area into 2 equal parts. Question number 19. Here we have again that we have 10 boxes and also 10 balls, and there are certain rules to move those balls around. After iteration, several iterations, all balls end up on the black box, which is 0, which is numbered as 0. So this is the number. Right? All right. Now we want to find at the beginning how many balls are on this box 4. Now for this problem, the most convenient way, at least to me, is to move backward. Right. So this is the final step, right? It's 10, 0, 0. So what's the previous step? How can you go from which step can lead us to the previous one, previous scenario can lead us to 10, 0, 0, 0? Obviously, it's 9. Okay, so we move backward. We go backward. The previous step, maybe I should read it's like this, right? So, okay, so how can I go to the final step? Well, what you do is 9, 1, right? 0, 0, 0, 0, 0, 0, 0, 0. Now that's the previous step. Will give us the 10, 0 because the box 1 has 1. According to rule, it will move to the 9, to the box 0, right? So this will give 10 and 10. Okay, how about then what's the previous one, right? What's the previous one? Well, to previous one, in order to get this, we will have is it's 8. 0, right? The only way you can do is 0, and here will be 2, 0, 0, 0, 0, 0, 0, 0, right? Now, if the previous step is 8, 0, 2, then of course now you see box 2 has 2 balls. According to the rule, the next step will move 2 balls to 1, 1 on box 1 and box 0, and it will give us 9, 0, 1, right? Now, how about the previous one? Previous step? Well, you see, in order to get, we'll get a 7, and this is 1, and this is 2, and 0, 0, 0, these are 0. Now, okay, because here, as you say, okay, box 1 is 1, the controller will move 7. But then you say, hey, but here I also have 2. Now, according to our rule, right? So the rule says if k is less than, because 1 is less than 2, so we'll work on box 1 first. That's according to this rule, right? If both box k and box n have special and k is less than, then we first work on box k. So this is like box 1. All right. Now, then by this rule, what shall be the next? All right. So the next will be 6. Right? So we just by the same, we just 6 and 0, and this will be 1, and this will be 3. Right? 0 box 3, because box 3 has 3. Then we just move all the previous one, and then okay. So we just buy the same thing. This will be 5. Here will be 1. Here will be again. This will be 1, and this 3, and this is 0, 0, 0. That's the previous step. All right, and then this will be 4, right? Okay, and this will be 0, 0, and this 2, and this is 4, right? If we box on 4, the next step is just move all the 4 to the to those previous, and then we have this is 3. This is 1, and this is 0, and this is 2, and this is 4. Now, because again, 1 and box 1 and box 4, they are both special, but by rule, we should work on 1 first. All right, and then the previous one will be, this will be 2, and this will be 0, and this is 2, and 2, and 4, right? Because again, 2 is special, 4 is special, but we work on 2 first. Now, further we move up, right? We move up the previous step. This will be again will be 1, and this is 1, and it has 2, and 2 has 4. And then previous step, this will be 0, 0. Here will be 1, 1, 3. And then, all right, so those are all 0, 0, 0, 0. And this will be 5, right? So this is the original position we are looking for, or original, right? Original, so that's, this is what we have. Because now this one has 5. According to rule, so this is box 5, right? If you go down, this is box 5. According to rule, it will put move to the 4 fireballs will move to the previous all those box 0, 1, 2, 3, 4. All right, so then you see the box 4, right? So this is the box 4. Originally, it has 3 balls. All right, here our strategy is we go backward. Question number 20. Here we have ABCD is a trapezoid paper. We have angle A equals angle B. They're both 90 degrees. AB is 10, AD is 15, BC 25. And then we folded the paper along the line, which is BD. We along the line BD. And this gives us a triangle BAD. AE and D. Okay, so then from here, we know this part, this one will just be 10 because it's the same as AB here. Okay, now we need to find the area of the triangle. So this is the triangle. We need to find the area of the triangle DEC. Okay, all right, to find the triangle DEC, what we do is let's find the height. Okay, so I draw the height to the side EC. Now this height is then obviously is the same as this one, and this is 10, and this is also 10. Okay, now in order to find the area, we just need to find the base, right? What it is, we just say, okay, if we are able to find what is EC, then we are done. Now EC has two parts, right? So this part, here we have this part. Let me try. Okay, so let's say this part. And all right, so this part, let's say this will be X, and this part we know. So this part is the same as right here, right? This one is 15. So this is 25 minus 15, which is 10 here, right? So we say, okay, this one will just be 10. So that's what we have. Now, to find the EC, we just need to find the X. The point is, if we see this is 90 degree, this is 9 degree, and this is 10, this is 10, and these two angles are the same. So clearly, these two triangles, they are congruent. Congruent means they're exactly the same. You can move one to the other by rotational translation. So I have a triangle. Maybe I put this as the edge point. All right. So I have a triangle which is DHE. It's congruent to the triangle which is B, A1 and E. That's the same. All right. So if this is X, then this is X. All right. And then this part will be, we have this part. What's this part? This part will be 15, right? 15 minus X. Now, by expressing those things using X, now we can set up equation. We can have equation. Equation of X. What's the equation? We apply the Pythagorean theorem to the triangle. So let's see, if we have a triangle, this is the triangle, which is BA1, and here's E. This is X. This is 15 minus X, and this is 10. We use the Pythagorean theorem, right? So we use Pythagorean to get apply here. So it's 15 minus X squared equals 10 squared plus X squared. Now we need to expand this one, right? Let's recall the algebraic identity. A minus B squared is A squared minus twice of AB and plus B squared. And similarly, we have A plus B squared equals A squared plus 2AB and plus B squared. Okay, so from here, we just get this is 15 squared minus 30X plus X squared equal 10 squared plus X squared. Now we can cancel X squared and X squared on both sides. This is 225, this is 100. So we get 30X equals 125. And we can divide 5 on both sides, right? So this is 30, 125 divided by 5. This will be 6. Here will be 25. So 25 minus 6. Now, if X equals 25, so this X equals 25 over 6. All right, and then we get the EC. So from here, we can deduce the EC is X plus 10. So it's 25 over 6 and plus 10. All right, and then we calculate the area. The area 1/2 times the height, which is 10. And then times 625 plus 10, and we get 5 times, this is 625 plus 60, so it's 5 times 85, right? 85, so it's 425. Now, and 425 and 6, they are relative prime, and this is according to the problem, this will be our n and n, so n is 425, n is 6, right? So we get n plus n is 425 plus 6 is 431.